Hello, everybody. Good afternoon and welcome to today's session. Once again, my name is Ridwan Salahuddin. I welcome you to Data Science Fundamentals, Pandas Predictions, one of the two programs we're currently running at Data Fein. So Data Fein is a free voluntary organization that has created a platform to train and mentor people in the field of data science to aid capacity building. So thank you for joining us today, and thank you for having me. So today we'll be discussing Introduction to Matplotlib Plotting Simple Charts. Matplotlib's Plotting Simple Charts. So we'll start quickly with a recap of the previous class. So we're on day 5, week 3, day 5. So we started 3 weeks ago. So 2 classes on Saturday and Sunday. Then last weekend, we had another 2 classes, one on Saturday and another on Sunday. So this makes it day 5. So we have so far discussed introduction to data science, to NumPy, to Pandas, and we did a number of things. So the last class, precisely, we discussed how to create a new column of a data frame. So you have a data frame and you want a new column that is going to be based off existing columns or anything. So we discussed how to create it. So we also discussed how to select subsets of a data frame using the iloc, excuse me, I'm going to edit this, iloc and reindex methods. So we also discussed how to sort the values in a data frame based on column values using the sort values method. So we also discussed how to merge multiple data frames together using either of using merge method. Using merge method. Then we also discussed how to extract summary statistics from a data frame using the many data frame, many statistic methods. Some of them are listed here: mean, median, mode, and the describe method that simply provides a general summary that encompasses things like mean, median, mode, count, the 25th percentile, the 75th percentile, and all that. And I think lastly, we discussed how to handle missing values in the data frame. So as we know that missing values are inevitable, especially when you're dealing with real life data. So you're bound to have situations where some fields are either voluntarily left blank or situations just made the values unavailable. Okay, so let's quickly demonstrate for the next 5 minutes or 4 or less some of these items from the last class. So we are reading. So we are reading in a Pandas data frame from an HTML. So this was discussed 2 classes before. So we can obviously read data from. We can read data from various sources, including CSV file, Excel file, HTML file, SQL database, and several other sources. So here we're reading from this GitHub page. So for instance, let's see what the file looks like. We've done this in the previous class, but for those that are joining us for the first time, they can at least pick So the data is on air quality. So this is what it looks like. And supplying this URL to Pandas, it's going to extract the data. So I'm running it, it's currently loading. Okay, there it is. It took a while because it has to send requests to the URL and retrieve the content. Then after retrieving the content, it tries to pass the content and extract the table in it. As you saw on the URL, there are other contents on the web page that are not table or tabular data. So it has to pass and extract this. So let's create a new data frame, for instance, that's going to be the product of the values in Station Paris and Station London. So let's call it Paris London. So we're going to have df.station Paris. So I'm going to use two methods here. Two of them doing the same thing but in different ways. Station London. So these two different things are doing the same thing. This is accessing Station Paris column, while this is accessing Station London column. So both of them would work. So that's it. All right, so we see a new column here, Paris London, as rightly named here, and we have the values there as well. Sorry for that, please. Sorry for the slight break. Okay, so we created a new column as seen. So let's try to select a subset using the lock method. So let's assume we want to select just 10 rows. So we'll do something like this. We want the first 10 rows. Then we don't want all the columns. Say we want just 2 columns. Say we want the date time column here, and we want Station Antwerp. So we do something like this. Excuse me. Sorry. Yeah. So we have just the first 10 records. So filtered using the lock method. So let's see how the iLock works. So this, we can pass in more column names than these, and we can also, this can also be different. This starting from the beginning to number 10. You could start from number 10 to any number, or from any number to any. So let's see iLock. So iLock works similarly to lock, just that you don't use the so in this example, we used the index. This is the index column. This is the index column, and this is the column. These are the column titles. So we're accessing the different columns using the column names. With iLock, we will be using the index number of the column. So if you want to do the same thing with iLock, so date time is index 0, while station Antwerp is index 1. So let's assume we want to access the same thing. So we'll simply pass 0, 1 here, and we'll get the same result as we did above. So assuming we want to extract specific index numbers from the rows as well. Say we want row 1, row 4, row 7, 6, row 9. So we'll do something like this, and we'll get that. You can see 1, 4, 6, 9. So let's check again. So sort values. So let's try to sort this data frame by station London. So here we'll say df.sort values. So and we pass in we pass in station London. I want to sort it by. So you can see that the values in station London, yes. So it's the table is sorted by the values in station London. As you can see, starting from 0 to none. And if you look at the index column, you can see that the numbers are actually scattered now. So you can set whether you want it sorted in ascending or descending. By default, it is an ascending order. So you might want to change it and say ascending false, and it's going to sort it in descending order, as you can see. So if you want it to be sorted by two columns, so you would have to turn this to a list by putting square brackets. All right, so there we go. It's going to sort it by 2 columns. So it's sorting it by station Paris, but starting with station London. So it's sorted by station London first in descending, then sorted by station Paris as well. Then we discussed merge. So we have just one table here. I won't be able to illustrate merge using one table. But let's see how to extract the summary statistics. So I'll just use the describe function, the describe method rather. So df.describe will give you summary statistic. So we can see count. So each station Antwerp, for instance, has just 95 records that are 95 records. Then station Paris has 1004. Station London has 969, and Paris London has 938 records. So if you check the mean, you have the mean, we have the standard deviation, we have the minimum value, the smallest value for each column, we have the first quartile, we have the median, we have the second quartile, and we have the max. So, and I think lastly is handling missing values. But I have a little bit of quiz for us. So I'm going to share the quiz in a moment. I'm trying to bring up the link so I can share it to everybody. Just a moment, please. Okay, so I'm sending in, I just sent in the link to the quiz. So everybody can access the quiz and try to get it done. So you're going to have 3 minutes to complete it. 3 minutes to complete the quiz. So we have 3 minutes to complete the quiz. As soon as we're done with the quiz, we'll move on with the class. So this is what the quiz looks like. We have just 3 questions there. Graded quiz 1, day 5. So this is the first question. This is the second. And the third is just a casual question. So let's try to complete the quiz, please. Okay, can everybody, or can some people unmute themselves and confirm that they've seen the link to the quiz?
Yes, I've seen the link to the quiz and I'm attempting it already. About to submit. Hello, can you hear me?
Yeah, hi. Yeah, I can hear you.
Okay, I've seen the link to the quiz. I'm about to submit the quiz already.
All right.
Thank you
very much. If you've just joined us, you've not missed much. We've only revised, we've only had a recap of the previous class, and there's a quiz that has been shared to the chat. So please access the link to the quiz and submit it within 2 minutes. So we'll be moving on in the next 1 minute. Yeah, so for the quiz is not going to be, it is graded, but it's not going to count towards your scores or your completion of the program. So what counts are your assignments. So we have so far given 2 assignments. There's going to be 4 assignments and 1 capstone project in this course. So if your intention is to complete this course and get certified, then you would want to ensure you complete all the assignments. So quizzes, it's optional, it's just for knowledge. However, it's important you complete the assignments if you want to be issued a certificate of completion. The 2 quizzes we've given so far, the deadline for the first is tomorrow. The deadline for the second assignment is on Tuesday. I think on Tuesday, if I'm not mistaken. So let's end on Tuesday or Monday. Please confirm from the classroom. So let's endeavor to get it done and submit in time. All right, so welcome back. I have just 1 response, so let's just move on. If you can't complete it, you can complete some other time. So let's just come back to the class activity. All right, so today we're discussing Introduction to Matplotlib, plotting simple charts. Okay, so Matplotlib is a very powerful. Okay, so what we'll be discussing introduction and installation, anatomy of a plot, creating a figure container for your plots, then types of plots, then simple plots, how to make simple plots using the Pyplot API, then PyLab module. Okay, so let's discuss the introduction to Matplotlib. So Matplotlib is a package, is a plotting package that is built to be similar to MATLAB. So if you've heard or you've used MATLAB before, So you think of Matplotlib as something that offers you the same things your MATLAB can do. So the difference being that Matplotlib is open source, while MATLAB is not open source. So not open source means that it's not left open for anybody to change and to access the source code. So you can't access the source code freely. You can't. It's paid. Basically, the paid software is a proprietary software. Okay, so it's also one of the things is also built on is NumPy. So anything in Python that is going to be tailored towards numerical computation most likely will be built on NumPy. I beg your pardon. So we've discussed NumPy before, and you already appreciate how important a package it is in the world of data science or numerical computation with Python. Okay, so you can basically create any kind of plots. It's a very, very advanced package that has a lot of awesome features. So you can do so many things with it. What you can do is almost limitless. So let's see anatomy. Okay, how to install it? Installing is just as usual, a pip install, as you would install most other packages. So you pip install Matplotlib. If you're installing from your command line, so you go to your command line, then you type in pip install Matplotlib. So if your pip has been added to your path, so you'll be able to run your pip install. Alternatively, you can run your pip install from Jupyter Notebook. What I've written here, so if you copy this and paste to a code cell, you can use it to install Matplotlib. If you're running Jupyter Notebook from Anaconda, I believe Matplotlib is one of the pre-installed packages. So anatomy of a plot. Yeah, so this is what the plot basically looks like. Yes, so what we have here. So let's see from the top now, from the top left corner. So here we call it a major tick. So tick is a tick where you have it. So this is a tick when somebody just ticks something. So this is a tick here. So these are other smaller ticks here. So, but I'm starting from the top. So this major tick because it's at the end of the axis. So here we have the title, the figure title or the plot title. Anatomy of a figure is the title. So this is the title. Next here we have minor tick. How different from the major tick? Because this is in the middle of the axis while this is at the end. So the tick at the end is called major while the one in the middle is called minor. So if you look at this as this is another edge, usually the edge of your grid. So these another major tick, and you have the label there. So if you see these are minor ticks in between. So these also are the edge of another grid. So it's also a major tick, and this is a minor tick. This is a minor tick. All right. So this is a major tick, and this is the label. So to the right we have legend here. So think of legend as especially in a situation where you have multiple plots on the same figure. So the legend describes what each plot is. So here now it tells you that the blue is blue signal while the red plot is red signal. So as usual, we will be pausing we'll stop the class by 5:30 and resume back immediately using the same link. So there's a limitation on Zoom. If you're not a paid user of Zoom, you can't have a meeting that exceeds 40 minutes. So we've run through 30 minutes already. So in the next 5 minutes or thereabouts, we'll stop it and resume back using the same meeting ID or URL. Okay, so coming back here, So this is a line plot. This is just think of it as a plot. It could be any other thing. So it's a line plot here, the blue line. So this is a grid. So this is a grid. You can see two perpendicular lines crossing. So it's a grid. So going further down, so here this tells us this is y-axis. So this is the label, y-axis label. So let's come to the right. Here we have markers. So if you're creating a scatter plots, unlike line plots where you have lines, so in scatter plots you actually have markers, right? So these are markers. This circular tiny bits are called markers. So going further down, so this entire object here is called the figure. The entire object is called figure, and that's what is explained here. So it's called the figure. So think of a figure as a container for the plot. So you have the figure like a layout. So from there you can now start plotting the axis and the markers and other things on it, other artists on it. All right, so here we have axis. So axis is the plural form of axis is a single with is. So axis is a plural. So axis is where you have two or more singular axes. So in this case, so the combination of this axis and this axis is what give rise to what we have in here. So and what we have in here is entirely called axis. I'm talking about including the plotted figure in it, or the plotted items in it, the line, the scatter. So you can think of everything as axis, because we're only able to achieve that because we have two singular axes that have come together. So that's axis. So these line plots, as I explained earlier, so these are called spines. These are called spines. So at the bottom of the chart of the figure, we have minor tick label. We've seen major tick label here. So minor tick label. So this is the major tick label, while this is the minor tick label. And here we have the x-axis label. So I hope we understand so far what the anatomy, because understanding this is crucial to understanding the things we'll be discussing subsequently, because we'll be making reference to some of these things by these names. Is there any question? I'm going to unmute everybody now. So you can unmute yourself if you have any question before we proceed on the very short break and resume back immediately. Does anybody have any question?
Okay, thank you very much, sir. When you explain the parts of the anatomy of a plot, it's not about the red and the blue lines there. I think I missed that.
Okay. These parts?
Oh, okay.
Is this the part you're talking about?
Yes.
Okay, so it's called legend. So what legend does is, if you have more than one plot, so you would want to label each plot. So here we have this blue line here, right? And it's a different plot. Here we have another line, red, and it's a different plot. So typically you would give this one a label. So call it maybe blue signal, as it's labeled in this anatomy. And here they called it red signal. So you want anybody reading you can label it without showing this legend, but whoever is reading it would not know the label for this and the label for the other. So, but by putting this legend here, so it tells you that this blue signal, this blue line here, you can see there's a blue line. So it tells you this blue line, you can make reference to it and say, okay, this is blue signal. And the red line is the red signal. So it could have, the description could have been something that it could be plot of trend of oil prices. That's the blue line, for instance. That could be the description. While the red could be rise of COVID-19 cases. So instead of the blue signal and red signal that's used to describe it here. I hope that answers your question.
Yes.
Any other question, please? Okay.
Yes.
Go ahead, please. We can't quite hear you clearly. Seems to be poor signal from your end.
Yeah, I said we can think of a legend to be like a key.
Yes, it's a key. So a key tells you what value it holds. So a key, blue signal is a key, and it tells you that it is representing or it's describing this blue line. So you can come here and say, okay, this blue line is blue signal because this key blue signal has told you that. So thank you very much for that contribution. So think of legend as a key.
Okay, I want further clarification on the tick, major and minor tick. What's the difference?
The difference. Okay, so you have, when you create a plot, you're going to have grid lines. So if you look at these grid lines, so this is the first grid line on the vertical grid lines. Now this is the first, this is the second, this is the third. So the major ticks are the ones that fall on the grid lines, while the minor ticks, they are just trying to create a more granular forms of the main calibration. Think of it as main calibration, and maybe, okay, if you look at your ruler too, so you have 0, 1, 2, but in between there are smaller ticks that divide it into smaller precision level. So yes, so think of it as the minor tick is creating a more granular precision. So if you look at this and think of it as a ruler, so this ruler starts from 0, 1, 2, 3. So these are the main things. But in your ruler, you'll find out that there are smaller ticks in between like this that will divide each successive items on the number line into smaller segments. So here it divides it into 1, 2, 3, 4. So that's what differentiates minor tick from major tick. Does that answer your question, please?
Yes.
All right, thank you. Any other question, please?
Thank you.
All right, in the absence of other question, we'll end the first session here, and we can resume back immediately using the same URL or meeting ID. All right, thank you. I'm going to end it. So welcome back. So we'll pick up from where we left off. We just finished discussing, describing the anatomy of a figure. So here we'll be discussing how to create a figure container for your plot. So before you can create a plot, Matplotlib requires that you create a figure. However, in the event that you somehow don't create the figure before proceeding to make your plot, Matplotlib is intelligent enough to first create the figure for you. So while it is necessary that you create your figure before you start plotting, if you forget to do it, it doesn't create any harm. So now, let's see in this example, figures can be created using any of the following ways. So let's see the first example. Creating figure using the PLT. So first thing to do is to import matplotlib.pyplot. So the plotting module in Matplotlib is called Pyplot. So you import matplotlib.pyplot as you give it an alias. So the convention is to use PLT alias. So you would want to stick with that convention because almost everybody does that. If you use a different convention, it makes it difficult for other people to understand your code. So I'll also import NumPy because I'll be using it. All right. So we said we're creating. Okay, so some people just joined, so I'll just step back a little bit. So we said the first step in creating a Matplotlib plot is to create a figure container for your plot. So there are a number of ways you can create a figure container. So think of a figure container as explained here. This environment itself, the entire thing that is contained in the plot is a figure. So if you don't have a figure, think of a figure as a canvas. Yes, think of it as a canvas that you want to draw on. So you first have to create the canvas and have it ready before you start plotting on it. So in order to create it, if you don't create it, there is no harm. Matplotlib is intelligent enough to create it before plotting, and you'll see as we move on how you can actually create a plot without creating a figure object first. So, but here let's see how to create a figure object. So using the Pyplot module in Matplotlib, so we will call on the figure method. So we have imported this as PLT here. We say plt.figure, and we'll specify. So we can specify a number of parameters. We can specify the number of figures we want it to create. So, but in this example, we're creating just one figure, and we are specifying the size of the figure to be a 10 by 8 dimension. So this figure itself just creates an empty figure with no axis. In fact, if you create it and try to print it, you won't see it display anything. So let's create the data to be plotted here. So I'm just creating a list here, and this list is based off the first. So now let's plot. Create a plot on the axis. So you call plt.plot. So plot is the method that is used to create a plot. So you pass in the parameters it takes. So plot can take a single parameter or two parameters. So it can either take x alone or x and y when you have it. So in this example, we want 0 to be plotted against the first item here, 1 to be plotted against the second here, 2, and so on. So after creating the plot, you'd want to show the plot. So you call the show method on your PLT. So plt.show. So understanding this is sufficient for you to get started with plotting in Matplotlib. So let's run it and see what it gives us. Okay, so a lot of times you see me run a cell without selecting run here. So the way I run a cell is by selecting either Shift Enter or Control plus Enter. Enter if you're using Mac, so it's going to be return. So that's how I create a plot. So somebody wants to ask a question. I'm going to try to unmute yourself.
Okay, I want to ask also, how do you bring in cell? Like you have a shortcut to do that?
Oh yes. Yes, so the shortcut is B. If you want it above, you use A. If you want it below, you use B. You just press B. So here now, you have to ensure that you've clicked out and you've not clicked into the cell, because it's obviously going to type any character you press. However, if you click out like this and press A, it's going to create it above. Press B, is going to create it below. So just illustrate, and I can delete with pressing D twice. Okay, so back to the crux of the matter. So we can see the plots nicely created here with the dimension specified. And we have our main ticks here, right? Major ticks. We didn't specify minor ticks, so it's not creating minor ticks for us. So this is basically what you can do with Matplotlib. So the next, as we proceed, we'll see other things we can do with it. So this is a figure here. We created a figure first, then we plotted into the figure. So if we didn't have this here, for instance, we won't be able to specify this dimension that we did. So another way to create a plot is using the subplot method. So if you call the subplot method of the Pyplot module, so it's going to return a figure object and the axis. So we've said the axis is actually the main plotting, or the main plotting that gets done on the figure. So it's going to return the two. It returns the figure object and the axis object. So here, let's run this. All right, so we can see it. It's created the figure. The figure itself, it's important to note that if in this first example, okay, let me just illustrate it by pasting it here. So let me run this. So this is, I'm still going to print. So this is not going to show you any shape or anything. So you can see it simply returns a memory location or something, a description of the figure. So it doesn't. So yes, it knows in the memory that okay, it's going to create. It has created a figure actually. So, but it has not plotted anything on it. So not even the axis yet. So, however, using the subplot method here, so it's going to create two things: the figure and the axis. And we can see here it's created unit axis of 1 by 1, x-axis 1 and y-axis 1. So that's what it creates, because we've not told it what to plot on it yet. So what if we want to plot something on it? We'll see as we move on. So here again, let's try to see what's contained in the axis. So axis as well just tells you it creates a memory location. You can see this is just telling the computer that okay, this object is going to be stored in this memory location in the computer, and that's it. And this is what gets printed here together with the figure object. Okay. So in order to create, so in this example here, we're going to create a plot now. So first as we did in the previous cell, we create our subplots. We call the subplot, and we have this. So here we'll now use the axis object to create the plot. So we now say axis.plot, right? So we already have this canvas set out here with the axis object. So we now want to say, okay, plot some items or plot some numbers on this axis. So that is what we're. So I hope this explanation is intuitive. I'm trying to make it as intuitive enough as I can, so that you can relate. So in the earlier example, it was plt.plot that we did. We created plot from the Pyplot module. See it here. But here, this is because we didn't create the axis and the figure objects. But here that we've created the axis and figure objects. So we use the axis object to create our plot. And that's what we do here. And so you can see it as plotted the values passed to it. So this is another example. The subplots method, it can take a number of arguments. So let's see. It can take arguments, number of rows, number of columns, and a number of other arguments. So many more arguments that it can take. But here where some have been defaulted, most of them have values defaulted. In this example, subplots here, the default is 1 row, 1 column. And that is why here, because we didn't specify the number of rows and number of columns, it only created 1 by 1, so which is just one object. So somebody wants to ask a question. Please go ahead.
Okay, sir. Actually, what I wanted to ask is,
can you be louder, please?
Okay, your Jupyter notebook, the way
Yes.
it brings out the help.
Okay,
that
so
happens on Google Colab, but I've not seen it on my Jupyter notebook like this before.
you use Jupyter Notebook as well?
Yes, I use Jupyter Notebook as well.
All right, so you'd once you've typed out the function or method, so you'd hold on Shift then Tab.
Okay, I think I should
Shift
write that
then
down.
Tab.
Thank you very
So
much.
if you do it once, it brings a high level help that you can scroll. Oh no, not really. It just brings the first few lines. So if you want to show more than this, you'd have to do it twice, or if you want it to, so I'll do it twice, for instance. Excuse me, sorry. Okay, so I do it twice, it brings it out and you can scroll through. But if I want it to even show more than this, so I can do it 3 times and it brings it to the bottom of my my page, so I can scroll through and see everything. Okay, so we move on. So this is going to create a 2x2 plot. So what's a 2x2 plot? Let's see what it looks like. So here we have a 2x2 plot. You can see this is 2 rows and 2 columns. Unlike this, that is just 1 by 1, 1 column, 1 row. So this is 2 rows, 2 columns. So we have 4 plot items. It could have been 2 by 1. Yeah, it could have been 2 by 3. So we can see it, and you can as well specify the figure size using your fig size method, fig size arguments. Okay, so in tomorrow's class, we'll see how to, this is actually called object-oriented method of using Matplotlib. So we'll see more of it tomorrow, and how to, like, how you can create plots in each of these subplots. So we have 6 subplots here. Okay, so moving on, types of plots. Types of plots. So we have types of plots listed out here. They are what you're familiar with. We have bar plots. We have bar H, which is going to make a horizontal bar plot instead of vertical. This makes vertical. This makes horizontal. We have box plots. We've discussed this in the Pandas class. Histogram 2D. They're quite intuitive. You can just read through them. And Pyplots, normal plot that plots a line, polar plots, scatter, stack plots, stem, step, quiver. So simple plots using the Pyplot API. We've seen it above. We'll do more of it now and see how to pass in some other arguments. So in this example, so what I did here is just to create the data, create the plot data. So you need not to worry about it, but we've discussed it before. So now calling the plots.plc.plots, which is what we've seen before. I said you can use the Pyplot module to plot. So we are plotting x against x times 3, so 3 times x. So basically, whatever values we have in this x, we're multiplying each of them by 3. So we're plotting this against it. So now what we're doing is we're plotting 3 things, but we want to have all of them on the same plot. So So remember I told you, here we're not creating figure. You can see that I didn't start by creating a figure object. But I told you, Matplotlib does well to first create the figure object before plotting. And what it does is create a default of just one figure, a 1x1 figure or subplot figure. So it creates single figure, and all these things will get plotted on the single figure. So we are plotting three things. The first is this. The second is x against x squared. And the third is x against x cubed. So all the values here, I'm going to print it out so that when I run it, you'll see what values are in there. So what I'm doing here is I'm specifying what color by this B, and here how, what type of, how do I explain this? You'll see, once I print it out, you're going to see what it looks like. Tells you how it's going to plot it. There can be different ways. So now, here we can also set the labels. We've seen in the anatomy of a Matplotlib plot, we've seen that we can have X label, we can have Y label, we can have the title. So here we'll see how to set the X label by calling the X label method on the Pyplot module, Y label method on the Pyplot module, then the title method on it. Then we call show at the end. So let's run it. So what I did was print the data, which is this. You can see what it looks like. Then it plots this data against the Y equivalent that we created on the fly here. All right, so let's see what the chart looks like. This is what it looks like. So you can see the way it's plotted, it didn't use continuous line. So I specified it using this here, this thing here. And the color is what precedes the, should I say, the shape. I don't know how to describe it, but I believe everybody understands what I'm saying. At least I'm pointing to it here. So this part is what describes it, that, okay, use a dotted line or a broken line to plot it. Here as well, use a broken line. I can change it. If I don't specify it, it's going to use continuous line. So you can see this green has changed to continuous. We'll see more of it as we move on. And we can see that the title, simple plots. Did I put simplet? Simple plots. And we have the x-axis, we have the x-axis and the y-axis labels. So y label, x label. So let's move on. Another example, let's create a scatter plot using the data from here. This same data is what we're using. So create a scatter plot. So now the scatter plots, you have to pass in two values, x and y, your x values and your y values. So our x values are what we have here, or is what we have here, and y value, we're creating exponential of the x. So each item, remember we talked about vectorization in NumPy. So this exponential function is going to get vectorized, and each item in this array will be raised, will be the function is going to be applied to it. So you're going to have exponential 0, exponential this till the end. So as well, we set the x label, y label, the title, and we show it as well. Very similar to what we did, just that in this example. Okay, no, it's a bar graph we're creating, not a scatter plot. I beg your pardon. So bar graph. So let's see it. So there we have it. So bar graph, we can see it. A bar graph is the title. We can see the label. We can see x label, y label. All right. If there's any question, you can indicate by raising your hand. So in the next example, we create our x values, a random numbers, 100 random numbers. Our y values as well, we create it here. Then we, now, before, we have other things we can also specify. So this method here, xlim. So if you want to set limits on each axis. So let's come back here. If I want it to start, here it started before 0, right? If you wanted it to start from 0, and I want to specify that explicitly, I can do that. If I wanted it to start from -10, I can specify it explicitly. If I wanted it to end on 4 here, even though we have more data that spans beyond 4, I can achieve that. So that is what xlim and ylim methods do. So with this xlim method, I'm going to set the left that, okay, on this x-axis starts from, the x limit is 0.2, so start from 0.2. The right limit is 1.5. Stop at 1.5. Discard don't show any other thing beyond 1.5 on x-axis. So let's run it and see the scatter plot. So we can see it starts from 0.2 and it ends at 1.5. It doesn't even get to 1.5. Yes. So for instance, if I don't have it, let me comment this out. We'll see how it plots it. It starts actually from way before 0 even. So from minus 2 point something, and it ends at around 3. If there's any question, please ask. Indicate by putting your hand up and you ask the question. So the next example here, we're creating, you can see we're creating plots.py. So intuitively, you know it's a pie plot. We're creating a pie chart rather. We're creating a pie chart. So we specify the x. You know, in creating a pie chart, we only need one set of values. The other set is just going to be maybe the labels that are going to identify each value. So for instance, we have a class of male and female. So you have the average score for males to be, say, 50, average score for females to be 30, and you want to plot it on a pie chart. So you only need to plot 50 and 30. You don't need information about the boys and girls, but you may still need it because you want to know which segment of the chart belongs to boys and which segment belongs to girls. So here we create a label with numbers. We make it numbers. So 0 to 10. We have 10 items here as well in the X. So you will use this to create the labels and pass it in here. So very straightforward. We have it. So if these labels were other things, maybe names, strings, it's going to as well put them appropriately. Okay, we're almost at the end of the class. Yes, so Pylab module is what we're discussing before we round up the class. We'll be rounding up in less than 5 minutes. So Matplotlib is actually, I think, is subclassed from Pylab module. So using this Pylab module, if you can actually import all the functions, this Pylab module has all the functions that Matplotlib uses to create plots. So if you don't want to if you want to access these functions directly, you can actually import all the functions at once from this Pylab module. So that's what we do here. So from Pylab, import star. So star refers to everything. So mostly in programming, when you see import star or when you see anything referred to as star, it's referring to all things that are available in that container or in whatever is being referenced. So we're importing all the functions, all the modules inside it, or all the methods rather inside it. So it has all the plot method, the x label, y label. So we can access them without having to prefix any of those methods with PLT or Pyplot. You get? Okay, so let's see. We're basically doing almost what we've been doing so far. So here we're creating plots of x against y, line plots, and we're telling it that we want the color here to be blue, and we want the line to be this shape, So we'll see it, and we want to also give it a label. So here we're creating two plots on the same figure, on the same axis. So two plots on the same axis, but we are assigning labels to them because we want to create a legend. So let's run it and see what we have. Here we have a very nice set of plots. One is sine graph, the other is cosine graph. So we see very nicely created. If I want to vary this, I can change this to, for instance, star, and we can see it creates, it creates it with stars. We can change to something like this. Oh, excuse me. Beg your pardon. Yeah. So we can change to something like this, and we can see the plot is a little different again. So we can have variety. You can play around with it and create things that look visually different and appealing. So we have a label, set label. We didn't set a title for it, so it doesn't have it. So here as well, this legend, we can specify where we want it to be. So, but we won't be going into that today. If you go through the help, the documentation for it, you see how to set the location of the legend. So we have come to the end of today's class. I have some practice problems here. So as you revise this, you should try to solve these practice problems. So at least it will ensure, it will reinforce what you have learned. Once again, if you are yet to complete your assignments, we have given 2 assignments so far. Anything you learn, you can only get better by practicing. If you don't practice, you won't really improve much. You might be under the illusion that you're understanding everything, you've learned it, but you find out that within a very short time, you can no longer remember most of the things you think you remember. If you're giving the assistant, okay, create a Matplotlib plot for us, you have to start looking for Google because you can't remember. But when you practice, you find yourself remembering most of these things easily. So I encourage everybody that's part of this class to practice consistently. It's only by practicing that you can get better. If you don't practice, then you won't get better at it. So dedicate time to practicing. So somebody wants to ask a question, please go ahead.
Thank you very much.
Yeah.
I want to ask a question about the grid, the minor grid. It seems you've not actually said anything about it. I don't know if you're still going to get there, but I want to know, can we, the way we have the graph, can we have the minor grid displayed, like, you know, the way we have a normal graph sheet?
Okay, if you want to have the grid as shown in the anatomy, this grid, right?
Yes, yes.
Okay, so it's actually grid. It's not really minor or major, it's grid. You can't have minor. So you can have the grid displayed, and it's part of what we'll be discussing in the next class. Okay. So it's part of the modules that are available. If you want it to display grid, you specify and many more. So there are actually limitless things that can be done with Matplotlib. So the class is only going to be an introduction and an icebreaker to at least get you to a level that you can start creating the most important plots. So if you want to also learn more advanced things, you can just go to the documentation, Matplotlib documentation. If you go on Google, for instance, and type Matplotlib documentation. So you're going to get, it's a little slow. So you're going to get the documentation of Matplotlib. So here, matplotlib.org. So if you click on it, so you can learn other things. Or for instance, what you want to do is create a grid. So you can just go and say how to add grid. Add grid to Matplotlib, right? So, and you learn about it, but it's going to be what we'll be discussing tomorrow as well. So it's going to be part of what we'll be discussing tomorrow. So, however, we can't discuss everything about Matplotlib. I'm not sure we can even cover up to 2% of it, if I'm not overestimating it. So, so yeah. So because there are a lot of things that can be done with it. So we'll be discussing it tomorrow. Any other question, please? Any other question? Somebody has typed in something. Okay, so thank you as well. Message well received. Okay, in the absence of any other question, let's just endeavor to practice. Only by doing so are we going to get better. So thank you for having me today. Thank you for tuning in. I do have a lovely evening. All right, bye.
Thank you, sir. Thank you.